we get on to some problems where we are going to work on two parallel lines cut by a transversal. It's the same stuff we did the other day. I just want to take a second day to make sure we get it down pat. I said in lesson 3 that this was one of the most famous diagrams that you'll ever find in all of Euclidean geometry, and it is. So I want to make sure we dedicate enough time to be fully prepared and ready to rock on it. So this diagram is a numeric one only. There's no algebra required, and I tell you that one of these angles is 120 degrees. Your job is to find the rest of them. Stop and start. Okay, so I'm just going to look at it as, let me find all of the obtuse angles, and every one of them will match this 120 degrees. And then I'm going to say, okay, what's the measure of an acute angle? Well, remember, one acute plus one obtuse adds up to 180, so 60 degrees is the magic number. And I will fill all the acute angles in with 60 degrees. So that is, or those are the angles in this particular diagram. Okay, now we get on to a little bit more challenging, and we'll start doing some algebraic type of stuff. Go ahead. All right. So these are alternate exterior angles, which we know are congruent, or you could look at them as both acute, which would make us know that they are congruent, or if we did drag and drop, they would end up vertical to each other, which makes us know that they're congruent. So the first thing I'd like to mention is kudos to math, because no matter where you begin from, you are going to arrive at the correct, only absolute solution. If we were studying other disciplines like history, the conservative, the liberal, the progressive, the Republican, the Democrat, the socialist, they might all find 5 different answers to a particular question. That is not the way of math. And I've said before, and I'll say many times this year, I find that comforting, that we can find agreement despite how we start. You want to start with drag and drop? Go ahead. You want to start with acute obtuse? Go ahead. You want to remember alternate exterior angles are congruent? Go for it. Either way, we're all going to end up with the same solution. Okay, so since we're going to end up with the same solution, we realize that 4x plus 16 equals 7x minus 20. Opposite side, opposite operation, subtracting the 4x. I get 16 is 3x minus 20. Adding the 20, that gives me 3x is 36, or 36 is 3x, a little more accurately said. Dividing by 3, 12 is equal to x. I don't spend a lot of time talking about these equations when I'm done with them, but you can just rewind the videotape and get the exact same thing play by play. And then, of course, as always, if you're still confused about any of these, you can just reach out to me for office hours or a friend, or send me an email, and I'll do what I can to make sure we straighten it out. Maybe put up another quick video and say, hey, a couple of kids had some questions about this. Thought I'd come at it from this other perspective and see what we get. Next up. Go ahead. Okay. This time I have an acute and an obtuse, so they're going to add up to 180, or if I did drag and drop, they're going to be exactly next to each other, so they make a straight line, adding up to 180. Same side, same operation, combine like terms. 7x plus 19 is 180. Minusing the 19, I get 7x is 161. Dividing by 7, I get x is 23. Perfect. Go ahead, stop and start. Okay, now these are alternate interior angles, and I know they have to be congruent because they're alternate interior angles. I could also say, hey, you know what? They're both obtuse. Let's make them congruent. Or I could say, if I did drag and drop, they'd be vertical, making them congruent. Again, I find that very, very, very comforting. So 3x plus 16 is going to equal 5x minus 54. Always like to start with the x's, always with the smallest number of x's. I don't like left or right. Subtracting the smallest number of x's, which is 3x, I get 16 is 2x minus 54. Adding 54, I get 2x is 70. 70 is 2x. Dividing by 2, 35 is x, or x is 35. Same deal. Once you get the equation set, it's the same thing over and over and over again. Not only with these line segments. They could be equal, they could be supplementary, adding up to 180. But even in the three angles of a triangle problem, we find that we get problems where they add up to 180. Or perhaps we're doing supplementary, they add up to 180. And though you'll never get it with these, or you'll virtually never get it with these parallel lines, complementary adds up to 90. So it's these same techniques with solving equations. And if you have any difficulties, it's very important we get those straightened out. Otherwise, you can know the geometry and still have problems with the algebra. Yeah, the algebra caused you to get it wrong. Okay, give it a shot. Here you go. I hope you're confused at the end of this question. I hope you're very confused. 4x plus 2 is 3x minus 2. Subtracting the 3x's, subtracting the 2's. X is negative 4. Strange. Okay, let's take the negative 4 and plug it in here. 4 times negative 4 is negative 16, plus 2 is negative 14. 3 times negative 4 is negative 12, minus 2 is negative 14. That's great, it checks. The only problem is you cannot have a negative angle. So sometimes you might get a weird answer. Be on the lookout for. If you cannot have a negative angle measure. If anything like that ever kicks up, you would say that it's impossible. You couldn't do the question. Here we go. Find the value of x in this diagram. Go ahead. Now, there are no way to categorize number angles 1 and 3 because they're not alternate interior. While they are exterior, they're not alternate. So there's no way to really categorize these particular angles. So we just realized one's acute, one's obtuse. Or if you did drag and drop, angle 1 would land on top of angle 2, putting them next to each other and making half a circle or 180 degrees. So they add up to 180. Same side, same operation. That is combining like terms. I get 11x minus 7 is 180. Adding 7, 11x is 187. Dividing by 11, and we get x is 17. Okay? All right. One last problem to do here, I believe. Yes, I think this is the last one for the day. Go ahead. First, solve for x. You're going to need 2 angles for that. Then solve for y. You're going to need 2 angles for that. Okay, so you've done stop and start, I assume. Let's solve for the x's. And what I have with the x's is alternate exterior angles, or they're both obtuse. So 17x minus 70 will equal 2x plus 5. Opposite side, opposite operation. That gives me 15x minus 70 is equal to 5. Adding 70, I get 15x is 75. Dividing by 15, and I get x is equal to 5. A little tough to come out with an obtuse angle there, but we'll just give it a kind of a Picasso-like, Monet-like, Rembrandt twisted perspective on the angles. Okay. Next up, to get the y's, I realize one is acute and one is obtuse, or they're consecutive interior. And consecutive interior says to me that they add up to 180. Same side, same operation. Combining like terms. 8y plus 20. My y's I combine to 8y's. My 5 and 15 I combine to 20. Subtract 20 from both sides. 8y is 160. Dividing by 8, y is 20. And that, folks, brings us to the end of the slideshow. Some review work on the angles of parallel lines being cut by a transversal. And at this point in time, you can review as much as you need to review. You may want to do the homework first, but you're going to have your first quiz to take. It'll be due in a few days, and you can take it starting today or for over the next couple of days.